I'm going to use the car example to demonstrate inheritance and polymorphism in object-oriented programming. I have a script up and I have Python 3.13 ready to go. So let's go ahead and begin. I have some code pre-written, so I'm just going to cut and paste to save the typing. And the first thing I want to do here is create the parent class for car. And so, as usual, we have the reserved keyword class, which means what's going to follow next is the name of the class, and in this case it's car. We're using the reserved keyword def for define, then the double underscore init, because this is going to be our constructor. This is our class method constructor, and we have self, which is required to create our different class properties here. And then this one has what, 1, 2, 3, 4 parameters: make, model, engine, and year. So these will be arguments we passed to these parameters, and then we'll have our class constructor set up. So the first thing we need to do is we need to create some self, and we're going to use self make. I'm going to go ahead and just paste these in real quick. Okay, so self.make, model, engine type, and year. These are just things right here that I made up for these properties, and they're going to be assigned to the values make, model, engine type, and year. And so the make here, whatever arguments passed here will go here. Whatever argument is passed for model will go into this model here on the right side, and so forth. And then these values will be assigned into the self.properties. Okay, so that is the class method constructor. Now the next thing we're going to do is we're going to create a couple of class methods for this parent class. And I'm just going to go ahead and throw them in fairly quickly here. The first one is describe. So whenever this class method is called describe, of course it will inherit all the properties of self right to here, and you can see the F here stands for the embedding of these three class properties: the self.year, self.make, and self.model. And you can see that because of the curly bracket open and close on each one of these. And so this is going to say this vehicle is a, and then we're going to pull in the self.year, self.make, self.model, and that's what it's going to print out if this is if the describe method is called. Now the type engine, we could do something more interesting, but this is just going to be the engine starts quietly. We are going to override this class method later on in our other classes. Okay, so this right here is the parent class, and it is completed. Now we're going to make a child class, and the first one we're going to build is the child class sedan. I'm going to go ahead and just throw the full class in there and then explain it. So here's the child class sedan, and as you can see on line 16, it inherits car, so that's the parent class. So all of the properties and the class methods are pulled in when we say car. Now we're going to have we have to have the class constructor for sedan, so we still have to have a constructor. Therefore, we have the double underscore init and double underscore, and then of course our parameters that we're going to use. Again, we have to have self. We're going to have the make, model, engine type, year, and you'll notice that this child class is going to have a couple of extra parameters. This one is seats, and we're going to assign it to 5. We're going to default it to 5, and then we have the MPG, miles per gallon, and we're going to default that to 30. Now here we have the super reserved keyword, which means that we're going to be taking these right here from the parent class. So we have to instantiate these. And then we have the self.seats equals seats and self.mpg equal mpg. So these ones here, because we're going to be using what's brought in from the parent class, and then these two are the additional ones that we bring in right here. And that, this part right here, is the class method constructor for sedan. Now we have type engine. And type engine, you can see we inherit all the properties of self from the sedan class. And we're going, if type engine is called, we're going to use self.make, and then we have some embedded text in here, so the sedans, and then self engine type, and then engine starts. Now you'll notice here we're going to override this. We're going to say engine starts smoothly and quietly. So that's going to be what happens here. Next, we have sedan features. This is a new class method. It does not exist in the parent class. And here we're going to say seats, and we're going to have the fuel economy MPG. So seats, the number of seats, which is defaulted to 5, and the fuel economy, which is defaulted here to 30 miles per gallon. Okay, so now we have the child class sedan has been created and is ready to go. Next, we're going to do the truck class, a child class truck. And the child class truck, again, is going to inherit the parent class car with all of the usual parameters, except for this time, unlike the sedan that has seats 5, we're going to have some different parameters. We're going to have four-wheel drive, and we're going to say true. So this is going to be a Boolean true value, and then towing capacity at 10,000. So we're setting that to 10,000, and these are going to be the default values. Again, we have to instantiate for the make, model, engine type, and year, and then we have to have our two brand new selfs for the two additional parameters that we're using. We have the type engine and the truck features instead of sedan features, truck features, and here we're using self.make, self.engine type, and we have a different output. Engine rumbles powerfully. For the truck features, we have, we say here that the drive is going to equal four-wheel drive if self.four-wheel drive, else two-wheel drive. Now, so line 39 is the more challenging line to understand. What we're doing here is we're saying we're going to do a check. We have a variable that we're going to call drive, and this is just something that we're making up on the fly right here, and we're going to assign it the value of four-wheel drive if the self.four-wheel drive. What this means here, if self.four-wheel drive, means that its value, it has a value of true. So for example, in the default value, it's true. So therefore, this right here is going to default to four-wheel drive. If, however, four-wheel drive, when it's called, is overridden, if a parameter is passed for this, and we say that it's two-wheel drive or anything else, it's going to default to two-wheel drive. And so it depends on this Boolean value of true. The towing capacity, however, is going to stay. There's no check for towing capacity. It's going to be 10,000. And then we, on the print on line 40, we output the drive, which is, remember, drive is just the, right here, it's this reserved keyword that does the check, and then the output, the resultant is going to be drive. That's placed right here. And then the towing capacity is simply going to pull in from directly from here. So here to here. And then we add on pounds, so we have a nice sentence that's output. Okay, now I'm going to throw one last one in because I'm a fan of muscle cars, and so we're going to throw in a class for muscle cars. And so let me do that real quick. So here we have the class muscle car, and so it also inherits from car. Again, we have our class method constructor, and it does the same thing as before, the exact same parameters that it has to pull in. And then we are going to have horsepower equal 450 and top speed 180. So it has its own unique attributes right here, our own unique parameters. And then, of course, they have to exist here in their own self.horsepower, self.topspeed. We don't have any else statements with this one. Here we're just pulling in the information and outputting it. So really, really simple. Nothing complex happening with this child class. Okay, so the next thing we're going to do is we are going to create an instance of each of the subclasses or child classes, and we're going to have to pass them some information. So again, I'm going to just copy paste that, and let's see where we're going to put that right here. I'm going to go ahead and make a, so it's kind of obvious that what's below it is something different than the classes. All right, so now we have creating an instance of each subclass, and we have sedan, which is assigned the sedan. Now this part right here, this is taken from the sedan class. So that's what's happening. We're calling the sedan class from up above right here on line 16, and we're passing it the parameters: Honda, Accord, i4 224, seats equal 5, MPG 33. The sedan class, let's see what it looks like. Seats equal 5. Probably don't have to put in the seats equal 5. It would default to that anyways, but we're going to leave it. And MPG 33. Yeah, so we did override 33, the 30 default. Okay. And then truck equals truck. We're calling the truck class. We're passing it these parameters. Four-wheel drive equal true. Towing capacity 12,000. I think we overrode it. Yep, if it was at 10, we were doing 12,000. And the muscle car, you can see it's the, I think we're using, yeah, we overrode 7 horsepower and top speed at 203. Well, yeah, that's fast. Okay, let's, now that just creates the instance. So if I was to run this, everything should work, but it's not going to output anything because all we're doing is creating the instances. As you can see that nothing happened. Well, I mean, things did happen, it's just that they're not visible. Okay, and then we are going to pull in, let's see here, the we have to now do something with those instances. And so what are we going to do? What we're going to do is we're going to create a list that demonstrates polymorphism. So what the list is going to be called vehicles, and that list of vehicles is going to be sedan, truck, and muscle car. So it's just taking these 3 instances and putting them into a list. So all this information is going to run through these different classes, and then all of everything that's returned is going to be in these single objects, and then these 3 objects are going to be placed here, and they're going to be entered into a single list called vehicles. Now we have that information, but we don't, now we have to do something with it. And the next thing we're going to do is we're going to create a for loop that's going to iterate through each of the vehicles in the list and pull out some interesting information. So let's go ahead and do that next. This is kind of cool. I'm going to just give it some space here. All right, so here on line 65, we have to demonstrate polymorphism clearly. So we have for vehicle in vehicles. So for every vehicle inside of the list vehicles, we're going to call the describe and the type engine property for each one of those. And that's here and here. Well, the describe is from the parent class right in here. And what's the other one? Type of engine. And that's the right here, type of engine here, and type of engine here in each of the classes. And so now we're going to get all that information. We're going to pull that data, and this is all in one giant for loop. So it's going to iterate 3 times, one for sedan, truck, and muscle car. And then it's going to say if the instance vehicle sedan, then vehicle sedan features and truck features and car features. Okay. Now, what this if statement is it's handling the different instance. So of the different instance of each of each vehicle type. So for example, here's vehicle sedan, vehicle truck, vehicle muscle car. So if it's the sedan, then do this. If it's the truck, then do this. If it's the muscle car, then do this. And then we have print just for a blank space. That means that the print here is so that you're going to have a line, a space between each car. Okay, so if we run that, let's see what happens here. If we run that, then you have this vehicle's a 2024 Honda Accord. Honda sedans i4 engine starts smoothly and quietly, seats 5, economy 33, and then you can read the rest. You can see that each of these is what we put in for each of the vehicles. Okay, and all of this data was pulled out in one using polymorphism right here in this for loop. So again, the list with the 3 objects, the objects embedded into the list. Then we pull out the list in vehicles, describe and type engine because that's common across the classes. And then here we have a nice little if statement to say vehicle sedan, truck, or muscle car, and then pull out the correct features for each one, and then a space between. All right, so that is what this looks like. I will put this code in my GitHub account so you can download this and try it for yourself. But it's a nice example of polymorphism and inheritance using both of those. Is there anything else I need to cover? Let's see. I don't think so. I think that's pretty good. You can play around with it. Try changing the seat numbers or removing the variable altogether. Try some different things and see what works. Okay, so that completes this this topic on inheritance and polymorphism in object-oriented programming, and that's it. Happy programming.